So already I'm seeing the cosmetic damage. It looks like it was dropped. Still, I think that is worth 130 quid to take off. Just a little bit of straightening a bit of steel. Question is does the thing work? Yeah, son. Do you want that? Because Daddy don't need it.
Well, me. Well, oh.
Yeah, so there's the instruction manual as well. Right then, let's see what the TIG torch is like. Wow, they've given me a WP-26, which is a bit more heavy duty than the 17s. Still, I've got a surprise. I've got a much better TIG torch than this coming. This is pretty good actually. That will certainly be kept for spares. Do you want a hand opening that up, son? Here we go.
Open that one. Open that one.
Yeah. It's good that they supply a little kid's toy with it, isn't it?
That's how.
This is a welding shield, if you can call it that.
That's my welding shield.
It's your welding shield, yeah, although I would never let you use this, so I'd give you something proper to wear. There you go, son. There's your welding shield. How am I going to even bother to read this jargon here? Once the contact take, give or get an electric shock. It's exactly the same as the last one, isn't it? What kind of specs we got here? 60% duty cycle, 250 amps at 20 volt, and it does stick welding at 250 amps at 30 volt. Apparently it's 100% duty cycle at 194 amps, and all off a 3-pin plug. You want to cuddle? Pre-flow, peak current, basic current, slope down, arc force, pulse frequency, pulse duty, clean area width, gas afterflow, poster. That's the on button, that's the amps, 42T AC DC, interesting.
Interesting.
Let's just see what's inside.
Yeah.
Ready?
Wow. Turn it on.
I will do in a minute. I need to make sure nothing's going to kill me first. So first things first, when opening her up, I found that the main power in, as those two cables there, are not connected to the switch. So those just need popping in. But I guess anyone else who wouldn't have known that would have just tried to turn her on, said, oh, she's not working, send her back. That should do her nicely. So what I'm actually looking for as I peer inside this thing is anything that looks off. So making sure all these electrical components aren't actually touching each other. Anything that looks bent gets straightened out. And just generally looking at the quality and the overall health of the thing. So apparently this works on IGBTs, which is what all of these are, which are a little bit like MOSFETs, but they're a much better quality. Swing her around, see the other side. It's a bit ominous. Bending down like that. Found immediately something else that needs fixing. See that little inductor? That's completely come off. Luckily it's all labelled on the board where it goes, so I could actually resolder that in no problem. I have to get around the back. See if I can simply get this out. So I see the area in question. I'm going to take that inductor off and put it this side where I can get access to the solder easily. Right, here goes nothing anyway, I'm going to do it. There you go, that's what I've got to resolder back on. There we go. Okay, so I've discovered another problem. Now, off camera, I've tried using it and there was too much power coming through. There wasn't any kind of fine setting, which was really irritating. What I discovered is these ports here and in there were actually soldered onto these ones, but it'd been done in a way that was by accident. They should, I believe, be kept separate. So what I've done is I've put this bit of what is shrink wrap insulation that you'd shrink around your wires in between these wires, just so there's a bit of distance between the two. I actually had to cut along with an angle grinder to cut the solder away from these rods here, and it seems to have done the trick. Now, bearing in mind, it looks like I know what I'm doing here, but trust me, I haven't got a clue what I'm looking at or really what I'm doing. All I'm doing is looking at what I think it should be, which is a very kind of dangerous thing to do, I know. So I'm not recommending that you copy anything I do. Really, I'm looking for your confirmation, people who do know what they're looking at. I'm looking for your advice and any advice that you can help other people with this, because I don't know everything. But I think that was a genuine problem to fix, and so far it's been working well. Right, this is my foot pedal that I bought specifically for this machine that gives me variability in the amount of amps that are delivered. Now, I've discovered another problem. I've been doing a few little tests already. I promise you I will be showing you my aluminium welding. This is a test I did. So far it's working okay. I've got a problem where straight off the bat with just the first click it produces 250 amps, and then when I go all the way down it turns the amps right down to almost nothing. So there's a reverse in the potentiometer that we've got in here. And it's very possible that it's the wiring that's the wrong way round in the machine, not the foot pedal. But I've decided to change it in the foot pedal rather than the machine, just because I know exactly what I'm looking at. I could theoretically change it just in the wire, but this is all soldered together in here and it's just a bit easier to just do it within the foot pedal itself. And I'll make it so I can reverse it back. Let me show you what's inside. So as you can see just there's a little potentiometer that mechanically works with a rack and pinion. These two wires here, there and there, need to be the opposite way around. So if I can explain how this works, one of these is an input, the middle one is the output, and what happens is there's like a loop of resistance. If you imagine there's like just a coil that goes around like that. The middle one has what's called a wiper, and that touches onto that coil, and depending on its position creates a certain level of resistance for the current to go through. So you can create a variability which you can then convert into variable amps. So one of these is starting from low resistance to high resistance when I put the foot pedal down, but I want it to be the opposite way around so I can get the variability that I want. There we go, that should work. Okay, so not my best welding, but I'm considering that to be fairly good. The foot pedal is now responsive, the machine is working fine, and it's going to do the job that I want it to do. Now, I'm pretty sure we could go into all of these settings, but there's so much to it, I probably won't just cover it in this video. In this video, we're doing the unboxing, we've given it a test, and I've got a project that I'm working on. I've got a whole load of aluminium work to do now, which is why I'm aluminium focused at the moment. But in the future, we can talk about stainless steel settings and maybe do really fine work using the pulse settings. And I'll show you my tips and techniques on doing that. But so far, my review of the Röhr is I'm kind of quite pleased with it. I've saved some money and it's certainly doing the job that I want. Okay, so let's talk settings on how I did this. Now, I'm using the foot pedal, so you can see the peak current, basic current, is all the way down to 0 and it's absolutely been bypassed. Now, the thing is with aluminium, especially on small pieces like this, is it's highly conductive. So what you actually require is a lot of amps to begin with to create heat into the weld pool. But then you start to notice it get to a point where it's wanting to melt through. You can see my bead's got a much more rounded profile compared to, say, the end here. At the end there, it's kind of more flatter and it's actually melting in. And I actually backed off the foot pedal quite a lot near the end here. So that's the benefit of using the foot pedal, is I can get this variable feel of the material, watching the puddles, seeing how the bead is forming, and back easing on and off as and when I need it to, depending on how hot the material is getting. Now, my tungstens, I'm using the white tips, these ones specifically. What kind of tip have we got? We've got a rounded ball tip. Can you see that? See the kind of shininess on it? How I achieve that is by turning the percentage of cleaning all the way to what looks to me is 80%, which they call clean area width. It's called the cleaning action. It's basically the difference between the negative and positive in the AC/DC. One will be smaller than the other, and in this case there's an 80% difference. When you do that, it balls the tungsten right up, and that's what you want. You want a nice little ball on the end. And then once I've got the ball, I'll then turn it back down to round about 30% cleaning action, maybe a little bit higher, maybe 35%, I reckon that is. So just to recap that, once you've got your tungsten, it could even be completely blunt. Turn your cleaning area width all to its max 80%. You'll watch it ball up once you've put some current through it, you know, test it on a piece of metal, then turn it back down. And I like mine to be around about 35% cleaning action. That will change depending on what you're doing, but generally 30% on most things I would use. Obviously, having it set to AC, and we're having it on straight out amps, not having it on TIG function, 2T. 2T and 4T, if you don't know that already, is click for on and let go for off on 2T. 4T would be click and let go for on, click and let go for off. That's how that works. So it's like an automatic function if you've got to hold it for a long time. We're using the foot pedal, so I can hold the TIG torch right on the very end and get a lot of control there. That's what I like to do, as long as it's not getting too hot. I might hold it a bit further back, but it means that I've got that much more control in the hand, and I don't actually need the switch on it then, really. So I'm using a number 6 cup, a fairly small one really, probably the smallest I'd go down to for the 2.5mm tungstens. And the reason is you don't need the gas to protect your material, you need the gas to protect your tungsten only. So having it as narrow as you can get just gives you that much more room flexibility. A smaller cup means less gas is needed also, so more efficient. Unlike stainless steel, where you'd like to have a nice wide gas envelope to protect the material. you don't need to for aluminium. Things that I recommend would be to put a 32 amp plug, not a 16 amp. This is just what I had, but it's far better than just using standard 3-pin. 32 amps if you're going to be using it on the 250 amp mark. And obviously with the correct breakers specified by your electrician. But if you like, very quickly I'll run across all of the settings, so you've got at least a basic of everything if you're going to wait for the next videos. We'll start with this, well, start with the on and off switch if you like. There you go, that's pretty obvious. Pre-flow time, that is a time delay setting of allowing gas to come through the torch prior to igniting the arc. This is ideal for things like stainless steels because you don't want the stainless to be contaminated by air and oxygen in the air. So to have a bit of protected gas, argon gas, to come first before you strike the arc is quite ideal, but just a fraction of a second is all you need really. Right, peak current, this is your basic amps. Now if I was using the switch here, I would control my amps using this. You've got from between 10 and 250 amps. When the machine's on, annoyingly it doesn't tell you what it is. It'll only tell you what it is if it's in MMA mode, if it's for stick welding. So the only way you're going to know your peak current is if you strike an arc and watch your dial. You can then set it. You've got to keep striking an arc and watching your dial. So a little bit annoying, but you can kind of guess where to go anyway. And you should be looking at how your material is behaving rather than just going off settings, because even there's a lot of factors that would make you change your settings. Using an automated setting or a setting that you've remembered and dialing into isn't the best way. Your best option is to go by the look of the bead itself, seeing it melt in, and you can get a feel and a dial for that. But that's my personal preference, to be honest. Right, basic current. This is for your pulse settings. So unpulse is basically you're going to go your peak current and then basic current, and it's going to go up and down, and you control your high and low with your peak and basic current basically as it goes on and off using the pulse function. We'll talk about that later. So slope down slope. So at the moment we've got our peak current on, so we press the trigger, immediately we've got exactly the current that we want. When we let go of the trigger, it will suddenly turn off. Now in some applications it's better if the intensity of the arc slowly dissipates out until gone. That way you can stop things like cratering happening in the end. So for instance, I'll show you what cratering looks like, because I've got some on mine. See those little dimples? Yeah, I could get rid of that if I did a downslope where I'm gradually easing off the amps, and that is preferable in a lot of cases. So that's that slowly dissipating amps is the downslope. Arc force, I think it's mainly to do with stick welding. I haven't really noticed much difference using arc force, but I'm assuming it's that peak intensity as you strike that arc. Right, so now we've got pulse frequency and pulse duty. Frequency is how many pulses per second you're going to get. So you've got between 0.5 and 300 pulses per second. Right, so we've got how many pulses per second in your pulse frequency, and then pulse duty is how big each pulse is on your peak current. So you've got your peak current is your high amps, basic current, low amps, and then your clean area width, or your cleaning action, is actually, is it 20% or 80%, or anywhere in between, positive or negative. So a lot of that won't make a lot of difference. This clean area width is the main thing you want to focus on for aluminium welding. Like I said, as you're going along, round about 35% normal. straight up to 80% to ball the end to get the correct tip. Depending on what you're doing, of course, and what tungstens you've got. Now the gas afterflow, the very last one, is quite crucial. If your tungsten is remaining hot and the gas shuts off before then, you'll oxidize your tungsten and destroy it basically. So you want to keep enough gas flowing once you've let go of all the amps, once nothing's happening. As the tungsten's cooling down, you still want to protect it with gas. Gas afterflow is what you control that with, or post flow as it should normally be called. This is also crucial for things like stainless steel, where you want to still protect the metal as well. That may still be hot, so it doesn't produce too much colour or overcooking the material, if you like. So continue to keep holding gas on it for a while until it's cooled down enough. Right, these buttons here, you've got your AC up, DC down, AC for aluminium, DC for steel and stainless steel. And then you've got your pulse settings and your normal settings. So straight up amps, pulse amps at the top. We use today straight up amps. 2T, click on and off. 4T, click on, click off. And then we've got TIG and stick welding. In the plug side, you can see TIG is always on the negative, so these two are bridged together. You see you've got stick welder there and a TIG on here. TIG is always on the negative side. The torch is always on the negative and the earth is always on the positive. However, there is something very funny here, is depending on what electrodes you're using, but generally a stick welder, the stick torch is always on the positive, normally, depending on what sticks you use of course, and the earth is on the negative. So make sure you get that the right way round. Certainly for 70-18 electrodes or 60-13s, it's pretty much always torch on the positive, negative on the earth. Right then, I've got a pond cover to make now, which is why I bought myself an aluminium welder. So something to look forward to in the next episode is this DIY powered air respirator. Now, we've already had a go at doing a DIY powered air respirator, but this is version number 2, and hopefully you'll be very impressed with what it can do. Something to look forward to. Right, hope you've enjoyed that. Please leave a comment if there's anything else you want me to do and develop on. I know I've still got a lot more to do on the other welder that I have not done a lot with, using things like flux core and stainless steel, all of that kind of thing. But as you understand, I'm actually doing real life work with all this stuff, so it's hard to go in between projects to do these review videos. But hope you like that. All the very best. See you in the next episode. Bye bye.